Okay. Next, under CPU scheduling, let us discuss the first algorithm, FCFS scheduling algorithm, along with the review questions. So from the name itself, we can understand it's given that first come, first served scheduling algorithm. So for a scheduling algorithm, the question will be given like this, either in wordings or a tabular column. The major interpretation is they have given that there are three processes. From this, we can understand that there are three processes P1, P2, P3. But the other thing is burst time they have given. That is the burst time is P1 needs 24 milliseconds, P2 needs 3 milliseconds, or P3 needs 3 milliseconds. There are common units, okay? And one more thing what we are missing here is our arrival time. We expect to have arrival time, right? But here arrival time is missing. If arrival time is missing, we have to assume that all arrived at 0. That means all are already in the ready queue. We need not bother when it comes. At the instant when the scheduler looks, all are available in the ready queue. So while problem solving, in the question, when the bus time is not given, when the bus time is given, when the arrival time is not given, consider write that as the arrival time is not given, let us consider arrival time of all processes are 0. All are arrived in the ready queue. Now, let's see. First come, first serve algorithm. From the name itself, we can understand each process is scheduled or picked by the scheduler from ready state to running state from the order of arrival. Who comes first will be first served. How to solve this? We know that we have the timeline representation of a process by using the Gantt chart. Now I'm going to represent a Gantt chart. Okay. Now, what is the first process in the table given? It is P1, am I right? So, we can write as P1 when it is starting 0. How long P1 takes? It takes till 24 units of time, either 24 milliseconds. So, I am marking it P1. So, P1 needs 24 milliseconds. What about the second process in the ready queue? P2. How long P2 takes? 3 units. So P2 takes the next 3 milliseconds. So it ended up at 27 milliseconds. At the last, again the next 3 is taken by, next 3 units of time is taken by P3. So 0 to 24 for P1, 24 to 27 for P2 and 27 to 30 for P3. Now, how to mathematically analyze this? From this process, you are write a tabular column like this that what is the process burst time given in the problem? What is the wait time? What is the turnaround time? What is the wait time? We already know that how to calculate the wait time. Wait time is equal to start time minus arrival time. When the process starts its execution in the running queue, that is in the CPU, minus arrival time. Here we already mentioned that the arrival time is not given, so I am considering arrival time is 0 for all. So when the process starts, that is the wait time. So for example, for P1, what is the start time? Start time P1 starts at 0. It also arrives at 0. So there is no waiting time for P1. For P2, when P2 starts at 24. P2 starts at 24 millisecond. So start time is 24 minus arrival time is 0. So it's 24 millisecond. For P3, similarly P3 starts execution at 27 millisecond. So 27 minus 0 is 27. So when you record the wait time for P0, P1 the wait time is 0. For P2 it is 24. For P3 it is 27. How will you calculate the turnaround time? It is the sum of burst time plus wait time. We have to add both. So 24 plus 0 here it is 24. 24 plus 3 it is 27. And 27 plus 3 it is 30. Now we have to calculate the average wait time, not only for individual process. What is the overall performance? So make it a sum. What is the sum of this wait time? Calculate the sum of all the wait time of all the process. make it as a sum. So I can make that 0, 24, 27. When I add this, what I will get that I will get it as 51. Right? So the sum is 51. When you take the average 51 divided by 3, it is 17. So average waiting time is 17 milliseconds. So average waiting time of these three problems using FCFS is 17 milliseconds. Similarly, when you take the turnaround time, I have 24, 27 and 30. Now when you add it up, what will you get that? 40 plus 30, 70, 70 plus 11, 81. 81 divided by 3, I will get 27 milliseconds. So when you take the turnaround time average, it takes 27 milliseconds. So this is how we will analyze the performance of each algorithm. I will calculate the average wait time and average turnaround time. Now, what happened? A long process first occupies the CPU and it increases the wait time for all the process. Now, let's analyze what happened when there is a change in order of arrival of these processes in the ready queue. So, let us assume that P2 and P3 arrives earlier before P1. All are arrives at 0. But the order when we are taking it that we are taking it as P2, P3 followed by P1. Now, let us again draw the Gantt chart how. What is the first process we are having it here? Yes, it is P2. How long P2 takes? P2 takes 3 units of time. So 0 to 3 P2. Again a 3 units of time. So 3 to 6 it is taken by P3. Again it is followed by P1 which it takes 24 units of time. So it starts at 6 and ends at 20 by 24. It takes total, it ends at 30 milliseconds. Now for this analysis, let's take what is the wait time. For P2, what are the wait time? P2 starts at 3 and it ends at 0. So 3, sorry, it starts at arrive 0. So 3 minutes 0. Again, now let us calculate the wait time of P2. So P2 starts at 3 and it arrives at 0. So 3 minus 0. Let us start with the P2. So for P2 wait time, start time minus arrival time, P2 starts at 0 and it arrives at 0. So waiting time is 0. For P2 it is 0. For P3 it starts execution at 3 here. Am I right? So 3 and it arrives at 0. So 3. You look at this P1. When the P1 starts execution, it is 0. So for P1, this is for P3. So for P1, it starts at 6 and it arrives at 0. It is 6. So when you record the wait time for each process, here it is 3 and here it is 6. So when you take the overall turnaround time, 0 plus 3 plus 6, it is 9. So when you take the average turnaround time, what will you get? It is 9 divided by 3. You have only 3 milliseconds. Similarly, when you take the turnaround time, 3 plus 0, 3. 3 plus 3, 6. 24 plus 6, 30. So overall what I will get? 39. So 39 divided by 3, I am getting only 13 milliseconds. Now look at the previous, when the order, the larger process P1, longer process P1 occupies the CPU first, I have an average wait time of 17 milliseconds and average turnaround of 27 milliseconds. Now, the same burst time, the process, any process didn't change its execution time, but it has the wait time of average wait time of 3 milliseconds and 30 milliseconds. So the order of arrival matters the most. Why it is that? What is the problem with the earlier one? A longer process or a process with a long CPU burst time occupies the CPU and it denies the allocation of CPU to other lower CPU burst time processes. So this is called as convoy effect. All the other processes wait for the one big process to get off from the CPU. Like how when a VAP is going on, all the other vehicles are blocked in the traffic. It makes a convoy effect. Am I right? Like that, the same thing here. A longer CPU burst time, a longer CPU bound process blocks the other short CPU bound process to execute. So this is called as convoy effect. This is called a convoy effect. And remember, FCFS SLM is non-preemptive because once it starts execution, until the completion of the process, the CPU doesn't release the process or the process doesn't release the CPU. So this is FCFS. The CPU is assigned based on the process that arrives first in the ready queue. Next question. Which of the following is a major drawback of FCFS scheduling? Starvation, convoy effect, requires preemption, and complex implementation. So just now in the previous example, we discussed that convoy effect affects the FCFS. That means a process with a longer CPU burst time blocks the other short CPU bound process to get the attention of CPU. It's called convoy effect. Next one, FCFS scheduling is preemptive, true or false? The FCFS process moves from running state to ready state before completion? No, it's possible. It's a non-preemptive, right? FCFS scheduling is non-preemptive scheduling. And in FCFS, which of the following determines the order of process execution? Burst time, priority time, arrival time, remaining time. So here, what we discussed already, it is nothing related to the burst time. Either short burst time or long burst time, it considers all are same. There is no priority associated. Arrival time, yes. Whoever arrives first will be served first. Remaining time, I don't know what is the remaining time as of FCFS. So in FCFS, the order is determined by the arrival time. The correct answer is the arrival time. Thank you.